Okay, this is going to be a test run with you guys, and just let me know what you think. What I'm planning on doing is recording me working down some notes and problems and everything for you. Then I will scan those notes and have a PDF form onto Canvas so you can see what I actually wrote if it's a little bit too hard. When you get done looking at this, please email me what your thoughts are, opinions, and everything like that. If you can hear me well, if this will work or not, because this is going to help me out as we progress through however long we're not going to be at school. Okay, so the next chapter that we're going to be on is chapter 15. And that is on equilibrium. Okay, so how do we know if something of reaction is equilibrium? Well, the way that when we're looking at a reaction, if we see a forward arrow and a reverse arrow, that is telling us that that reaction is in equilibrium. For example, okay, so forward arrow, reverse arrow, equilibrium. Now, do we need to balance it? Yes, absolutely. So our coefficient should be 1, 3, 2. Okay? Now, along with this, what we can do is we can find what is called the equilibrium constant. Now, the equilibrium constant can be represented with the K of C or KEQ. And the way that we find the equilibrium constant, we use our balanced reaction. And let's just use this one right here. To find the equilibrium constant, we take products over reactants. So our product for this one is ammonia. And if we have concentration, we take concentration of our products. So concentration of ammonia. And since it has that coefficient of 2, we're going to have to square the concentration over the concentration of our reactant. So we have concentration of N2 times concentration of H2, and that would be cubed. So if we were actually given any kind of numbers for the concentrations and everything, we would plug in the numbers into our formula right here, and that would produce the equilibrium constant. Now, the equilibrium constant is just a number. There is no units with it whatsoever. So let's kind of look at another example. Okay, so we have H2 plus I2 yields to HI in the reverse reaction, in the forward reaction. Then in the reverse reaction, we have HI decomposing down into H2 and I2. So if we put a coefficient of 2 in front of HI, then if we want to find the equilibrium constant, K of C is equal to concentration of HI squared over the concentration of H2 times concentration of I2. So it's not that hard doing this stuff right now. Now, these two examples, these are considered to be a homogeneous mixture because everything is in the same state of matter. We can have a heterogeneous mixture or heterogeneous equilibria, in which we have different things. We have reactants, products, in different states of matter. Let's see. Let me think of something real close. Let me kind of look up one real quickly for you. calcium carbonate. Okay, so if we look at the Ford reaction, calcium carbonate is going to break down into calcium oxide, which is going to be in the solid form, and carbon dioxide. So if we want to figure out what the equilibrium constant is going to be equal to, the formula for it for this one, since we have a heterogeneous equilibrium, solid, solid, and gas, KC would just be equal to concentration of CO2. Now the reason why I didn't put calcium carbonate or the calcium oxide into the formula is because when we find equilibrium, we only use gaseous or aqueous reactants or products. Anything that is a solid or liquid we leave out because their concentrations or their pressures, if we were going to be using pressures, they don't change that much. So I'm going to stop this for right now. I'm going to send it to you. Watch it. Let me know what you think. Thank you.